Today we have a discussion on intermolecular forces. As we have discussed about the forces, that is ionic bonding, covalent bonding, dative covalent bonding and metallic bonding. These forces were the very strong forces that is present between the atoms of one molecule. There are other forces that are exist between the molecules, between different molecules to attract them with each other. These weak intermolecular forces are also exist between the molecule. These forces are weak, and the intramolecular forces like ionic bonding, covalent bonding, these forces are very strong. Let's see. Here you can see the molecule of HCl. Hydrogen and chlorine, both atoms are attracted towards each other by the sharing of electron, and by the sharing of electron they are making covalent bond, and the covalent bond is very strong. Instead of this, between two HCl molecules there is weak intermolecular forces. These weak intermolecular forces are easy to break. If you want to break these intermolecular forces, for example, you just need 17 kilojoules of energy. Except this, if you want to break this covalent bond, as we discussed, covalent bond is very strong. So if you want to break this covalent bond, you need 430 kilojoules of energy to break this. So the forces that are present between the atoms of the molecule, those are intramolecular forces, and the forces which are present between the different molecules, those are intermolecular forces. Intermolecular forces are very weak and shown as a dotted line. You have to make a dotted line to represent the intermolecular forces, and the intramolecular forces like these are represented as straight line. Here you can see opposite charges are attractive towards each other of two different molecules, and the intermolecular forces are represented as a dotted line, and the intramolecular forces like this is a covalent bond is represented as a straight line. You need a less amount of energy to break this intermolecular force, and you need a high amount of energy to make this intramolecular force, that is covalent bond. In ionic compounds, ionic bond. In metals, metallic bond. There are many intermolecular forces like van der Waals forces. Hydrogen bonding are also considered as intermolecular forces. So let's discuss about one van der Waals force, that is dipole-dipole interaction. Van der Waals forces are basically the collection of the intermolecular forces like dipole-dipole interaction, dipole-induced dipole interaction, dipole-induced dipole instantaneous interaction. So these all intermolecular forces, all interactions are collectively called as van der Waals forces because the scientist van der Waals have discovered these forces. We are going to discuss about the one van der Waals force, that is dipole-dipole interaction. In a dipole-dipole interaction, by the name you easily get the point that dipoles will be formed. Due to that formation of that dipole, there is an interaction. As we know, there is attraction between the opposite ions. If there is a positive charge, it will attract the negative charge. So due to that attraction for positive charge towards the negative and a negative charge attraction towards the positive charge, they make a weak intermolecular forces. For example, this is a molecule A and this is a molecule B. These two molecules are considered as a different molecule. Due to the different molecule, the sharing of electron between these two molecules will be unequal. Due to that unequal sharing of electron between different types of atom, one end will be negative, partially negative, and one end will be partially positive due to the unequal sharing of electron. One end will be partial negative and one end will be partial positive. Due to that opposite poles, they will make a dipole, and these dipoles are basically the result of the difference of electronegativity between these two atoms. More electronegative atom, for example, this is a more electronegative atom, this will attract electron towards itself more forcefully, and due to less electronegative atom, this will attract electron pair towards itself not that much strongly. In the same way, in a molecule B, this atom is attracting a lone pair towards itself more strongly as compared to this molecule. So as I told you that positive and the negative having attraction towards each other, so this partial positive atom and this partial negative atom of another molecule will attract each other. Due to that attraction, they will make intermolecular bonding. These intermolecular bonding are very weak and you need very less amount of energy to break this and make the individual molecule a gaseous atom. But between these two atoms, there is a very strong bonding. You need a very high amount of energy to break that. So intermolecular forces are between the molecules, and these forces are basically a weak forces. Here you can see this example from HCl. Hydrogen is less electronegative, so that's why hydrogen atom contains partial positive charge. Hydrogen atom is partially positive atom, and chlorine is highly electronegative, that's why it attracts electron pair towards itself, that's why it contains partial negative charge. Due to the partial negative charge of this chlorine atom and the partial positive charge of another molecule of HCl, they will attract each other, and their attraction is represented as a dotted line because these are weak forces. Covalent bonds are represented as straight line. Intermolecular forces are represented as dotted line. In the same way, many molecules of HCl will attach with each other. Partial positive hydrogen, covalent bonding with partial negative chlorine atom, and another hydrogen molecule will again attach with this partial negative chlorine. In this way, many molecules are attached with each other by dipole-dipole interactions. In Br and F, there is also electronegativity difference. Bromine is less electronegative as compared to fluorine. Due to that difference of electronegativity, bromine having a partial positive charge and fluorine having a partial negative charge. Due to that partial positive and a partial negative charge, due to these dipoles, these two molecules having a intermolecular forces between them, and these intermolecular forces are basically dipole-dipole interaction, because dipoles are formed between the molecule due to partial positive end of one atom and partial negative end of another atom. Next, we having example of methyl chloride. In a methyl chloride, carbon is partial positive and chlorine is partial negative because of the electronegativity difference. Partial positive end of one molecule attracts the partial positive end of another molecule. Due to these dipoles, they attract each other as a dipole-dipole interaction. These forces are weak intermolecular forces. Next, we having a hydrogen bonding. We are not saying hydrogen forces, we are saying hydrogen bonding because hydrogen bonding are stronger than the van der Waals forces. Van der Waals forces are weaker than hydrogen bonding, and hydrogen bonding are obviously weaker than the main chemical bonding like ionic, covalent, metallic. Hydrogen bonding are basically weaker than these strong bonding, but stronger than the van der Waals forces. Hydrogen bonding is observed between the highly electropositive hydrogen atom and highly electronegative atoms with the lone pairs nitrogen, oxygen, and fluorine. If the bonding is between hydrogen as a highly electropositive atom and between the highly electronegative along with the lone pairs nitrogen, oxygen, and fluorine. Nitrogen having one lone pair, oxygen having two lone pair, as we know that. So due to that lone pairs and highly electronegativity, these atoms are making hydrogen bonding with the hydrogen atom. We are going to see the examples one by one. First example is of water molecule. As we know, in a water, one atom is oxygen and two atoms are hydrogen. Hydrogen is highly electropositive and oxygen is highly electronegative. These are the covalent bonding between the hydrogen atom and the oxygen atom. Due to the difference of electronegativity between hydrogen and oxygen, there is are partial positive and a partial negative charges on these atoms. As we know, oxygen having two lone pairs, so and highly electronegative. Due to that, one water molecule form two hydrogen bonds at a time with the hydrogens of other water molecule. The bonding between hydrogen and oxygen is the hydrogen bonding, because hydrogen is highly electronegative and oxygen is highly electropositive, and these bondings are represented as dotted line because these are hydrogen bonding. You have to represent it as a dotted line. Here you can see one water molecule are making two hydrogen bonds with the two hydrogen atoms of other water molecules, and between the atoms of the water there are covalent bonding. These bondings are very strong and need high amount of energy to be break, and these hydrogen bondings are weak and presented as a dotted line. So one water molecule is forming two hydrogen bonds. That's why boiling point of water is higher, because one water molecule is forming two hydrogen bonds. Next, we are having another example of hydrogen bonding, that is ammonia. In a molecules of ammonia, there is also a hydrogen bonding, because ammonia is nitrogen is highly electronegative with the one lone pair. As we know, nitrogen having one lone pair. That one lone pair is making a hydrogen bond with the hydrogen atom of another ammonia molecule. Due to the difference of electronegativity, they having a partial positive and a partial negative charge. Partial positive hydrogen atoms attract the partial negative nitrogen atom of another molecule. Due to that, they are making hydrogen bonding. Another example of hydrogen bonding is between HF. Fluorine is the highly electronegative atom of periodic table. As we know, fluorine having 4 electronegativity value. They make a hydrogen bonding in a zigzag manner like this. Due to the difference of electronegativity, fluorine having a partial negative charge and hydrogen having a partial positive charge. Partial negative fluorine and the partial positive hydrogen atom of the other HF molecule will attract each other as a hydrogen bonding, and these bondings are represented as a dotted line. Covalent bonds, ionic bond, metallic bond, dative covalent bond, all are represented with the lines, but when you are representing the weak intermolecular forces, hydrogen bonding or a dipole-dipole interaction, then you are going to represent them with the dotted line. So don't forget that intermolecular forces will be represented as a dotted line, and the bondings, covalent bondings are represented as a line. Answer this question. Which one from these four is the correct representation of HF molecules? The correct answer is D. Because covalent bond is represented as a straight line and the ionic bonding are represented as a dotted line in a zigzag manner. This is wrong because they do not make a straight chain. This is also wrong because here you can see this fluorine atom is not at the upper side, this is on the lower side. And this is also wrong because first atom will be partial positive and the second one will be partial negative. But here you can see partial negative comes first and the partial negative is second. So the correct representation of HF molecules is B. Due to this hydrogen bonding, water having a higher density and ice having a lower density. Due to that lower density of ice floats over the water. When ice is formed, the water molecule regularly arranged in a specific pattern. Due to that regular arrangement of atoms in ice, they having a 9% available spaces. Due to that available spaces, ice having a lower density. That's why ice float over the water. And due to that, marine life is exist because the upper layer of the water freezes and the lower water remains water and the marine animals stay alive under the ice layer. As we know, ice having a density that is 1 gram per centimeter cube and water having a density 1 gram per centimeter cube and ice having a density 0.917 gram per centimeter cube. So there is a difference of density between the water, liquid water and the ice. Ice floats over the water due to the difference of the density.